complex trinomial is quite a bit different than a simple trinomial, just in the way of factoring. Form is still the exact same thing. It's still an ax squared plus bx plus c, but the a does not equal 1. So for example, like a 2x squared minus 3x plus 5. It's a bit different. Now, factoring these trinomials does take a bit more effort since they are complex. So it should be more complex to factor when you compare it to a simple trinomial. So before we go on to complex trinomials, we're going to deal with some more simple trinomials. So just as a quick review, just to make sure that this is all good, our product is going to take the leading coefficient, multiplying it by the constant term. 1 times 6 is 6. Our sum is going to be our number in front of the x term. In this case, -5. So the two numbers that will give us a product of 6 and a sum of -5. Well, let's see. We could look at the numbers 1 and 6. 1 times 6 is 6. -1 times -6 is 6. But there's no way that we could get -5 from them, because 1 plus 6 is 7. -1 plus -6 is -7. Even if you try and combine them, even if you were to, by chance, say positive 1 and -6, well, yes, they add together give us -5, but they do not multiply to give us positive 6. So these ones cannot work. But the numbers 2 and 3 do work. A -2 and a -3. Multiply them together, you get positive 6. Add them together, you get -5. So to factor a simple trinomial, we just have to leave off our steps there. Write an x in the first spot, and write a -2 and a -3, and we're done. But when we're factoring a complex trinomial, these steps that we had done at the beginning of our last lesson, well, they're going to come back and we're going to have to do them. Now, I call them the steps for factoring a trinomial. What is called for factoring a trinomial, the method that this is it's called decomposition. The reason it's called decomposition is literally because of this breaking that x term into two numbers. So our steps, our process is still going to be the same. We're just going to have to follow these remaining 4 steps in order to keep on going. So for example, if we want to factor these complex trinomials, first off, we're going to have to set up our P&S chart. A product of our leading coefficient, our constant term. Now notice here that our first step to factoring our GCF, well, there's nothing common between a 2x squared, a 9x, and a 4. So we're all good. Product 2 times 4 is 8. Our sum, identify the coefficient in front of our x term, 9 is our next step. Still find two numbers that have the same product as number 1, same sum as number 2. So same product, same sum. The only numbers that would work would be 1 and 8. More specifically, a positive 1 and a positive 8. 1 times 8 is 8. 1 add 8 is 9. So here's where we do need to break down our x term into these two numbers. We need to break it down into a 1x and an 8x. So 2x squared. Just going to bring these down. So we've broken it down. Split the 4 terms in half. These are the steps that take the least amount of effort. Our real big work is number 6 and 7. What we need to do is we need to find out the greatest common factor and factor from the first 2 terms and then factor from the last 2 terms. So factor between a 2x squared and a 1x, the only thing common will be an x. We'd be left with a 2x add 1. Common factor between 8x and 4, while making sure that what we're left with is still going to be a 2x add 1, well, the only thing that we can factor is a positive 4. X factoring a 4 out, we're left with a 2x. A 4 factoring a 4 out, we're left with 1. You are not left with 0. You have to still write a 1. That way, when we're left with a 2x subtract or 2x add 1 and a 2x add 1, we can take that 2x add 1 in our last step of factoring that greatest common factor out in front. So we are then left with an x and a positive 4. One thing that I have seen people do is they forget this add 4 and they just write x4. That's just so wrong on so many levels. You have to include the entire x add 4. You factor out a positive 4, make sure you have it as a positive 4. And really the last example, 4x squared y minus 17xy minus 15y. Well, before we get to our product and sum, we need to take care of our greatest common factor. We have to factor it out. This one, the y. So that we can be left with a 4x squared, a negative 17x, and a negative 15. Then we can do our P and S. Product 4 by negative 15. Sum of negative 17. So now we need to find two numbers that have a product of negative 60 and a sum of negative 17. Well, if we're looking at it, factors of 60, 5 and 12 might work. But the only way we can get negative 17 is to have both of these negative. But negative 5 multiplied by negative 12 does not give us positive, or does not give us negative 60, which means these two numbers are wrong. You may get numbers that look that they appear right for one number, but you have to make sure that they work for both. If you don't make sure that they work for both, you're going to be using the wrong numbers. It's going to be a frivolous pursuit, and you will get it wrong. You have to do your steps correctly. The only numbers that would actually work would be negative 20 and positive 3. So I'm not forgetting about my y. Just going to leave it out in front. I'm going to break my x term into a negative 20x and a positive 3x. It doesn't matter which way you write it. We could write the 3 first and then the negative 20 after. They will all work out. As long as you follow your steps, follow what I've been saying correctly, you'll be fine. So broken down, split it up. I'm not going to forget my y. Common between a 4x squared and a negative 20x would be a 4x. What am I going to be left with? I'm going to be left with an x minus 5. Common between a 3x and a negative 15 will be a positive 3. Factor out what I can, I'd be left with a negative x subtract 5. You can see that there's an x subtract 5 and an x subtract 5 there. Not forgetting about my y. X subtract 5. And I would be left with a 4x add 3. There we're done. And there you can have fun.